evolved A stars with and without planets, and present statistics on that, including this beautiful resolved disk around Kappa Corbor. Go check that out. In poster 10, Mark Booth and colleagues examine a sample of debris disks around A stars that were resolved by Herschel and explore the limitations of black body fits to spectral energy distributions in locating the radius of the debris. So if you want to know more about that, check out this poster. Number 12, DeRosa presents results on debris disks within 75 parsecs in a volume-limited A-star survey, looking at the multiplicity of these with AO and the correlation and the multiplicity fraction as a function of whether or not these stars show 24 micron excess with Ys. And in fact, they do find an intriguing difference. So you might want to check out that poster for more details. DeFrere summarizes XE-Zodi detections and limits from the Keck interferometer nuller on 41 stars and describes the expected improvements coming with the LBT interferometer. And it looks like there are big improvements, so check that out. In poster 15, Steve Ertel shows from near-infrared interferometry that up to 30% of all main sequence stars have hot XE-Zodi dust. Check this poster out to find out why. In 16, Fung and Artimowitz present a study of instabilities in dusty gas disks induced by radiation pressure at the inner edge, where the disk transitions from optically thick to thin, an effect of the shadowing of the dust. Some interesting instabilities. In poster 17, Hartman et al. Modeled a spectra of gas disks around white dwarfs that result from the disruption of planetesimals. There are actually quite a few posters about white dwarf debris disks, so this is just one of them. Check them out. In poster 18, Wayne Holland describes Scuba 2 legacy survey of a very large number of debris disks using the JCMT at 850 microns. This is already more than double the number of image disks at this long wavelength and has resolved some interesting structures. In poster 19, Hughes et al. Present millimeter interferometry from KARMA and the SMA of 5 debris disks around young sun-like stars, and includes an in-depth discussion of HD 61005, which is known as the moth. So if you want to find out more about the moth, check this out. In poster 20, Jackson discusses models of giant impacts and the observable consequences of the debris. Mark Wyatt spoke a little bit about this in his talk. It's a fascinating poster, and I think has the best title in the session, Light from Shattered Worlds. Something you'd see in the airport bookstore. In poster 22, Kroll and colleagues describe a new code that combines grain dynamics with collisional effects in a self-consistent way. In modeling debris disks, this seems like an incredible advance to me, and shows a beautiful example of the time evolution of the violent breakup of a massive planetesimal in a debris disk. That's quite remarkable. In poster 24, Learn et al. Present models of this huge debris disk around HD 207129 resolved by Herschel, and it seems to require both an outer ring and an inner component, and this leads to some, I think, surprising consequences. So you might want to check that out. In poster 29, Patel and Metchev provide new statistics from WISE observations of mid-infrared excess on a large number of nearby stars. In poster 30, Marshall Perrin has reprocessed Hubble Space Telescope NICMOS observations and recovered 5 debris disks in scattered light, and maybe one of your favorites is here. Go check that out. In poster 31, Ritchie et al. Present a detailed abundance analysis for 29 solar-type stars with debris and discuss whether or not there's evidence for pollution of the stellar atmospheres from the planetary material in the debris. In poster 32, Stark presents new Hubble Space Telescope STIS observations of the debris disk around HD 181327. Beautiful observations, and they use very sophisticated models to disentangle the effects of density asymmetries and projection and scattering phase functions. And I think all of this has applications to many other scattered light disks. So this seems like an important advance. And finally, Philippe Thébault explores the complex behaviors of debris disks interacting with planets using a code that models grain dynamics and collisions in steady state. The spatial variation of the grain size distributions shows some very interesting effects. So check out this poster for more information. And it's time for the coffee break, so please be back.